Smart homes can be installed in a code-compliant manner to improve the health, safety, and welfare benefits of the user, and may even save the user some money. The focus of this 2-hour program will be to introduce smart home components and concerns while later walking through the setup of a low-budget smart home with the focus on energy controls. There's a lot to learn, so let's start out with a safety topic. Here's an example where a hacker infiltrated a home and pretended to be Santa Claus. Google later announced one of their web camera partners had a vulnerability which allowed third-party access to home security cameras. Google's response was to cut off access to cameras until the vulnerability was patched. This is alarming, but on the other hand, many users of cameras would be just as annoyed to learn their camera service was interrupted because someone else's camera was hacked. As much as the public is alarmed about internet security, we are even more enamored with cloud services which invite such insecurities into the home. The smart home designer will always invite the risk of failure into the home despite the advantages of smart home technology. Pushing the limits of the technology too far can be a costly error. Cloud services, which require an internet connection, can provide convenience, stability, and value, but that internet connection will always mean the device services could be lost, disconnected, or hacked. Cloud services provide the best voice commands, for instance, ones that have obvious advantage to health, safety, and welfare. Voice controls such as Amazon Alexa or OK Google offer new ways of accessing home lighting and other devices. Home Assistant, the open source home automation platform we will use later in class, has partnered with a privacy-oriented voice service called Alta, powered by the Stanford voice engine Almond, but its features are still in the early stage of development. For now, for voice commands to be useful, they can be easily connected to Amazon or Google cloud services. Voice commands have immediate use. What if an automation accidentally turns off a light that needs to be turned back on? It almost seems natural in a smart home to yell out to turn on the light, so how does that actually happen? It is possible to set up a secure internet connection to Google or Amazon cloud services directly in order to avoid subscription fees. Home Assistant charges $5 per month as a cloud service fee to connect to Google and Amazon in a secure manner. This is not a programming class, so I suggest paying the fee. However, it can be avoided with enough hacking. If you're like me, you might already own a Google or Amazon voice speaker, such as Alexa, in the house. In any event, I don't plan to implement my own voice control configuration, and I'd like to control all of my smart devices by voice using these speakers that I have. So there's no better excuse to sign up for the Home Assistant free trial of their cloud service and get voice commands going. After accepting the invite email, I'm prompted to enable Home Assistant within Google Assistant. In other words, I need to use the Google Home or the Amazon Alexa app to give it permission to talk to Home Assistant. My Home Assistant devices are then pulled into Google Home. Immediately, I can tell Google Home to turn on or off my dehumidifier smart plug. I can make voice command changes to my thermostat settings. I can ask the status of these devices as well. This is cool because my $65 programmable thermostat was not intended to be voice activated, but because of connecting it to the Home Assistant platform, it now has those features. Because it was an Internet of Things device, code has been written by third parties to connect it to voice services. My home is now voice activated using Google's cloud service. But unless I am an advanced programmer, I will end up paying some form of monthly subscription fee for this convenience, even if it's modest. Facial recognition for building security is much more likely to be a cloud service than run on a local computer. A cloud service doorbell that has facial recognition might be more useful than a non cloud doorbell that lacks it, unless that non cloud doorbell is connected to a very powerful computer that runs its own kind of facial recognition software as the cloud service doorbell does on a third party server. Companies are commercially incentivized to fund and develop cloud services. So cloud services are sometimes cheaper or sometimes more functional than a more secure local device. Cloud devices are definitely easier to use than local secure devices. But cloud services also invite security risks, such as the visit from the Christmas Grinch we saw earlier, or simply losing access to these devices during external circumstances like a failure in the internet connection. Building design is changing. I like to think of how smart homes could benefit new construction for cost savings. Could the thermostat be installed directly on the indoor unit, eliminating the wire run through the wall? Temperature sensors from any room could serve as the trigger, so a living room mounted thermostat is no longer necessary. How else might building design change? Might power over Ethernet devices require running Ethernet cable to the window curtains or replacing AC lighting circuits? Is National Electric Code even ready for smart home devices? Let's start with 21070 lighting outlets required, dwelling units, habitable rooms. At least one switch controlled lighting outlet shall be installed in every habitable room, kitchen, and bathroom. The definition of habitable room is not found in NEC, but rather in International Building Code as a space for living, sleeping, eating, or cooking. Bathrooms, toilets, closets, and hallways are not considered habitable spaces. So while not all rooms in the smart home are code mandated to have light switches, code does require most rooms have at least one light switch, but not multiple light switches. So, code is less clear as to whether or not the wall switch must actually be a manual switch like a traditional light switch, or if it could be a wireless switch. But I think an inspector could put his foot down to demand a hardwired switch. There's also the spouse acceptance factor to consider. It would not be in the best interest of the health, safety, and welfare of the inhabitants to invite negative emotional reactions into the smart home by not providing the users with a manual fallback in the event of a smart home failure. This is interesting because some of the smart home light switches require rewiring the light switch and actually taking it out of the circuit, routing the power circuit through a controller tucked away behind the light switch in the junction box, while rewiring the actual light switch as a low voltage relay rather than a traditional 120 volt traveler switch. A particularly hard inspector might suggest that a relay on the wall is not the same thing as an actual electrical switch on the wall. And also, the relays do not work as well as a physical light switch physically redirecting the electricity, as the relays only detect flickering voltage of a low voltage circuit circulating through the light switch, whereas a traditional light switch would actually carry the 120 volt circuit through one of two traveler circuits, switching back and forth between the two switches. It is possible to retrofit two-way or three-way light switches, but it's also more difficult to do so than to retrofit a single light switch. It's much easier to install these controllers when there's only one light to control, not two or three, through separate switches. And I do think it is appropriate to have at least one hardwired light switch on the wall in every room, providing power to at least one hardwired light bulb, so that you don't overkill with smart technology and have, all the lights in your home not work because you wanted to have something weird like battery powered light bulbs and no, hardwired light switches on the wall. So I don't think smart homes are ready to eliminate all the wires from all the walls. In fact, I think for new construction, I'd caution a smart home designer to remember that battery-powered devices which mount on walls or ceilings rather than doors or windows will usually have a powered by USB or powered by Ethernet option. In new construction, it's usually a better choice to go with a hardwired power option rather than to rely on batteries so that the device can be used more frequently and no longer require the batteries to function. The batteries could then be useful in power outages as well as to address other power quality issues. Now, power quality issues are particularly close to my heart as I'm a solar installer. So LED lighting is powered by DC current, but AC current is easier to transmit by the utility. So each DC light bulb in a building has to go from home AC power to DC light bulb power via a little inverter in the DC light bulb fixture. Off-grid solar homes have other inverters to convert DC solar electricity or DC battery electricity into stable AC output, or just converters to go from DC to DC before going through an inverter to go from DC to AC. These energy conversions can create voltage flicker in cheap LED lights, a problem that can occur with grid connection but can become worse in an off-grid setting. The easy solution is to use high quality LEDs, but that can be a difficult solution to retrofit. The future of lighting may well be powered over Ethernet lighting circuits, providing 24-volt DC lightings directly to the light bulbs, powered by an Ethernet switch and backed up with an uninterruptible power supply. The future of buildings may be renewable solar homes with off-grid capability, but that really isn't where I want our focus to be today. There are smart lighting solutions for AC circuits, so customers won't get left behind by installing traditional lighting systems today. And so for today's class, I'd like us to think modestly about our smart home design. Certainly, there are future-proofing issues to consider in new construction, which could be made today. To me, the Achilles heel is window blinds. Powered window blinds need power brought out to them, and I think it's a good bet to plan for window blinds to be powered over Ethernet. Indoor video cameras are another device which might not be installed in the home today but could easily be tomorrow. And so running additional Ethernet runs to windows and potential cameras is a good future-proofing step in new construction. And then, as a rule of thumb, remember that a hardwired smart sensor is better than a battery-powered one because it can always be on and sensing and communicating without requiring the replacement of batteries as a regular chore. So our smart home still has traditional light switches on the wall and Even if they are smart light switches, they are similar to light switches and are installed by a competent electrician. Because the wires on light switches or the tuck behind controllers are rather tedious and can become safety hazards if improperly terminated. Especially when these behind the box controllers are jammed into the back of the junction box behind the safety switch. I've only used the behind the box controllers, and I feel like a full switch replacement would be easier and improve workmanship and cost about the same. Let's leave our lighting discussion behind to talk about wireless communication protocols within the context of safety. First, these alternative wireless platforms are no more safe than Wi Fi. One wireless signal is not more safe than the other, in the sense that these communications can still be encrypted or unencrypted. So, encryption will slow down the signal, and it requires the other devices which relay the signal to also be encrypted. So, sometimes the performance loss on encrypted signals leads to poor signal quality and poor device performance, which isn't preferable for systems that should be responsive, such as security alarms or door locks. A Wi-Fi device, such as one provided by a cloud service like Google Nest or Alexa, can result in hacking issues with customer data being stolen. But at the actual site, that strong Wi-Fi connection with good on-site security can perform better than a lower powered signal such as Z-Wave or Zigbee. Other devices might not need a robust Wi-Fi signal to function, and so can be taken off Wi-Fi completely. An unencrypted, low-energy Z-Wave signal may find it hard to infiltrate a Wi-Fi network, whereas a Wi-Fi device is more likely to be powerful enough to do some damage if it had some malware on it. Of course, encryption is no good if the devices are hacked on the cloud side of the service or the customer side of the service, such as through poor password security. A common practice for smart homes is to select a Wi-Fi router which can set up a second virtual Wi-Fi network that is supposed to be independent of the primary network. The problem with cloud services is that they inevitably want to connect to your personal account, which might not be on the Internet of Things network, as well as to the Internet of Things network. So vulnerabilities ultimately can be difficult to isolate, and sometimes the best is to stay off the Wi-Fi system completely. Local encrypted networks that do not involve use of the facility Wi-Fi do exist, and they can be encrypted, and they do not require a direct connection to the building's internet for their wireless communication to work, and that can simplify the rollout of smart products on facilities where there are internet access concerns by the building owner or manager. These wireless protocols or platforms or signals, whether they're Wi-Fi or Zigbee or Z-Wave, they use different communication frequencies, which offer minuscule advantages compared to each other for particular uses. But that's usually trading off signal quality for reduced cost and increased battery life. So a Wi-Fi device would have great signal quality, but use more batteries and perhaps cost a little more than these lower energy Z-Wave or Zigbee devices. That can change with economies of scale, where the Wi-Fi devices are just made in such great quantities that they end up not really having a cost disadvantage. But these Zigbee or Z-Wave networks are really no more secure than if the same devices were Wi-Fi devices communicating locally on an independent Wi-Fi router or a completely isolated virtual server, except for the fact that a Zigbee device or a Z-Wave device is less likely to be harboring malware due to their reduced capabilities and smaller distribution channels as compared to smart home behemoths using Wi-Fi cloud services like Google or Amazon. So we're going to conclude the security discussion with the understanding that cloud services are all but inevitable. Having internet in the home means that most people are already purchasing cloud services. Amazon Alexa, Ring, and Nest are no different than Netflix and Disney Plus, or even a cell phone or traditional utility provider, and that they will collect sensitive data in exchange for providing valuable offsite services to the home. We can all agree that security and privacy are good things, and there are options available for customers who prioritize those values, which can be Wi-Fi based or not. The smart home platform that I use is capable of Wi-Fi or Ethernet connections. It's a $40 Raspberry Pi. I then add a Z-Wave antenna to the Raspberry Pi computer via a USB outlet. The rest of my devices are Z-Wave based and do not require the internet to run. Any of these devices would have to use my Raspberry Pi to hack my network, and so only one point of internet connection really needs to be sniffed by a security gateway for any malicious activity. An even more secure device hardware might have more limited functionality. For instance, the host computer not having a Wi-Fi antenna at all, needing a hardwired Ethernet connection to connect to the network, a dedicated mini PC with a Linux-friendly computer processor can serve as a nice host for a home automation machine.